Okay, so today we're going to continue our discussion on solving systems of linear equations. And this time, instead of graphing, we're going to use what's called substitution. So graphically means, how do we solve system of equations graphically? What do we do? Oh, we graph them. Yeah, we graph them. Why do you think graphing is a little bit limited in terms of, could it always work? What would be the advantages of graphing and some of the disadvantages? Why would we want another way to solve a system? Oh, bingo. That's exactly why. It's hard to graph fractions. And if lines cross at a fraction, you cannot be sure what the solution is. Because remember, what is the solution to a system of linear equations? Yes, where the lines cross. And that's the point that they both share. It's a solution in both equations. So we need another method, and our method we're going to use today, we have two different kinds of methods. We're going to learn the second method next time. This time we're going to learn about substitution. Now, if I were sick, Carol Lee might sub for me, right? She would be my substitute. We're equals, kind of, you know. We're not exactly the same, but we're on the same level. And that's the thing about this equation here. We're going to read the equation in just a second, or the word problem, but C equals 4P. Think about that as me equal to Carol Lee, or another instructor, okay? So example 1, let P be the cost of peanuts per pound. Okay. So what did they do there? When they say let P be this, what do we call that? Yes, so we defined the variable. Let C be the cost of cashews per pound, because I really bring that up because if it didn't give you a variable and it just started out with a word problem, but you didn't know what the thing, you're trying to find something, you would want to introduce a variable. So if that weren't there, that would be our first step towards solving, okay? But I guess we're going to talk about peanuts and cashews. If cashews cost 4 times as much as peanuts, oh yeah, that seems very accurate. They're a lot more expensive. We could write the expression, it's an equation, C equals 4P. Why is that an equation and not an expression? Yeah, it has an equal sign. If 2 pounds of peanuts and 1 pound of cashew cost a total of $18, we could write the equation 2P plus C, because 2 pounds of peanuts plus 1 pound of cashews equals $18. Does everybody see where we got these equations from and they kind of make sense? We could have written them. That would have been harder, but we could have written them. We could have started with just that information and written these two equations. And that's what you'll be doing eventually when we get to the harder problems. Okay, what is the price per pound of peanuts and of cashews? To answer this, we will write and solve a system of equations. So again, we could graph these, but it's also a little tedious, right? We have to get out our graph paper, we gotta put the scale on, draw a line, everything like that. It has to be graphed accurately. That's also a hard thing about graphing. But since I have C by itself and C is equal to 4P, what we can do is what's called a substitution. We can say, well, you know what? C is sick for the day. C's going home sick, but don't worry. We've got C's substitute, 4P. They're equal to each other, right? So wherever I see a C down here, I'm going to substitute in the 4P. So our new equation that we're going to solve, this is part of solving using substitution. We're going to substitute that 4P in for C. So we get 2P plus 4P equals 18. And the reason why this is so cool is because, well, why do you think it's so cool? Why would I even, what's the advantage to even doing that substitution, do you think? One variable. You can actually only solve an equation that has one variable. You can only, solve and get a number. Before, last time we were rearranging and we were trying to get things into y equals mx plus b. That was solving for one variable, but because there was an x still involved, we didn't just have one number, right? So now, how many p's do I have altogether? 6p equals 18. Can I solve for p? Yeah, what would I do next? Divide by 6. P equals 3. So what does that mean, p equals 3? Oh yeah, because now that I know p, I could find c. And I like how some of you were already starting to translate. What is the price of peanuts is the question. So the price of peanuts is $3 per pound. And now I want to find out what the price of cashews is. I know their relationship here, so why don't I go ahead and find P? Now, what I like to do, I like to be as efficient as possible. I need you to check them in both, but I'm going to show you kind of a workaround where you can check and find C at the same time, right? So if I plug in 3 for P, I'm going to get C equals 4 times 3. Because we already know that P is equal to 3. So that's basically a substitution too, isn't it? Cashews cost how much per pound? Yeah, cashews cost $12 per pound. And now, since I used the first equation, and this is the second equation, since I used the first equation to find C, and I already know that 3 and 12 work, and I always tell you you need to check in both, but if I go ahead and make sure I do the check in the second equation, 2 times 3, because P is 3, plus 12, is it equal to 18? 6 plus 12 equals 18. Is that right? 18 equals 18. Okay, so I've done, as long as you make sure now, I would always say check in both, and then of course you want your sentence answer right here. We have our sentence. We answered the question. You should always go back to answer this, solve. Okay, I solved. I did my checks. If you plug it in, like when I'm saying solve for one variable, find it, find your other variable in one equation, check in the other equation. Otherwise, you really need to check in both. And it doesn't save that much time to not check in both. Why don't we just check in the other one? Okay, 12 equals 4 times 3, right? That's our second check, but that's from the first equation. All right, anyway. So the process here, so this is the steps that we went through. The substitution method is a method for solving a system of linear equations. You solve one of the equations for one variable. Now, in this case, we didn't have to do that because we already had C by itself. So sometimes the first step is like, well, it's already done for us. Does that make sense? And then you're going to substitute the expression found in step 1 into the other equation. That's what we did here. And the result will be a linear equation in one variable. That's why we were able to solve for P. Solve the equation containing one variable. That's what we did here, step 3. Use the value found in step 3 to find the other value. You will need to use the original equations or the equation you obtained in step 1. And then 5, check your solution in both. And then if it's a word problem, you always want to write 6, answer word problems in complete sentences. Okay? Any questions on that? Now I'm going to show you, just to get you started, the first step. Not on number 2. So number 2, I'm going to ask you to do it. It already has y by itself. So when you substitute in for y, make sure you use parentheses, and that whole thing is going in for y. You see that? Okay. Now let's look at example 3 for a second. Neither one of those equations have a variable by itself. So you can't use substitution unless you're doing the first step if it's required. Here it is required because I don't know which variable, I have to find out which one I want to put by itself. It really doesn't matter which variable you get by itself, but you're going to be plugging one equation into the other. So which one do you think looks like it would be easiest to solve for? The first one, the 2x, okay? And do you want to get x by itself or y by itself? Y, okay. So then if we're going to get y by itself, we're going to, first, this is going to be our first step. Take the 2x plus 2y equals 10. And we're going to get y by itself. That was the choice. It really wouldn't matter. You could get x by itself. But since we're in the practice of getting y by itself, let's do it that way. So what would we do first to get y by itself? First step would be, yes, subtract 2x from both sides. We get 2y equals negative 2x plus 10, right? Does everybody see how I got that? And what would be the next step? Divide everything, both sides, right? Y equals, what would it be? Negative x plus 5. Did everybody get that? And when you substitute now, you would be taking this, since y is equal to negative x plus 5, they're equal to each other. You're going to substitute that in right here for y into this. It has to get substituted into the second equation. And that's going to look like this. 3x minus 4 times negative x plus 5 equals negative 12. Do you see the substitution, that substitution step? Does everybody understand how that worked? Now, I'm going to actually take you even one step further. And the reason why is because some of the most common mistakes happen right here at this point, and that's the distributive property. And it's because this is a negative 4, right? Does everybody see that that negative belongs to the 4? So when you distribute, you have to be really careful about your signs here. We're going to get 3x, negative times a negative gives you a positive 4x, and then what's negative 4 times 5? Yeah. Okay, so the reason why I wanted to walk you through that, just that part, is because that's where we make that's where I would say, 90% of mistakes in all math have to do with positive and negatives, but especially when it comes to distributing a negative, okay? So does everybody sort of get the process? Yes. Yes. Now, I wouldn't have had to just use y. I could have actually solved for x, and then I would be substituting in for x. Whatever variable makes the most sense to get by itself, without hopefully introducing a lot of fractions, Okay. Why don't we stop there and have you guys do those practice problems? So you'll do example 2 and example 3, and then we'll do some more problems together.